So we have discussed the velocity diagram of the single-sided crank mechanism. Uh, Today I will discuss the another method of analyzing the velocity of any configuration, that is eye center method. So wait so that I can add a new page or page. So it is eye center method. Previously, we have discussed that if we want to find out the velocity of any link in the configuration, so we can find out through the velocity analysis, or specifically we can say that we can identify or we can evaluate the velocity of any point on the link through the relative velocity method. But we are having one more method to analyze the velocity of the things, that is the eye center method. First, we will discuss how this eye center is going to affect the mechanism and how we can locate the eye center in any configuration, given configuration. So before that, there is a short note which can be discussed, that is the velocity analysis. That is the velocity analysis, and this velocity analysis can be done into two ways. First one is the relative velocity method. Relative velocity method, which has been discussed earlier into the class. Yes or not? Ayana.
Yes, sir. Yes, sir.
And second one is the eye center method. So we will discuss the eye center. I will take one or two odd classes to complete these things. Then we will move to the gyroscope. Eye center method. What is eye center? So eye center is nothing but instantaneous center. Instantaneous center. What is the meaning of instantaneous?
Sir, at that instant, मतलब
At that
तुरंत उसी
instant
time.
only. At that instant. This center is valid for the instant only. Yes or not? As we have calculated the velocity into the relative velocity method, the configuration is given at the fixed time only, na? Yes or not?
Yes, sir.
Because we have to calculate the velocity of every link, or we can say the every point or a lot of point onto the given link when the configuration is fixed. Means it is given that when the crank is moved through 60 degrees from inner dead center, and the velocity, angular velocity of the input link is 5 radian per second, then only I have to find out the velocity of the each point into the given configuration. Yes or not? So we can always calculate the velocity at a given instant only. We are not able to identify the velocity for the moving link. So I have to take a picture of that configuration at any instant of time, and I have to draw that configuration, and then only I can find out the velocity of any point on the given link. So this eye center method is nothing but the instantaneous center, and instantaneous means at the given time or at any instant. So this center is valid for the given instant only. If I am calculating the velocity at t equals to 2 seconds, then it is valid for the t equals to 2 seconds only. If the time progresses, say it becomes t equals to 5 seconds, then this analysis got lapsed, and again we have to calculate all these things, or we have to follow all the procedure which has been followed earlier for the t equals to 2 seconds. Am I clear?
Yes, sir.
कहने का मतलब ये है कि अगर t equals to 2 सेकेंड और t equals to 5 सेकेंड दो गिवन different instant of time है, then we have to calculate the velocity for t equals to 2 seconds separately and t equals to 5 seconds separately. We have to do two analysis for the two time for the different instant of the time, because this is valid for the given instant only. So if I'm saying that, say this is the link, say this is some kind of link, and the name of this link is OA, which is hinged at point O, and the angular velocity is given as omega. So can anyone is able to tell which kind of velocity OA have or OA has?
सर रोटेशनल
Pure rotation.
नो सर हिंज्ड है ना सर
हाँ, pure rotation ना बेटा. It is a kind of, if I'm saying that it is hinged at this point, so it is able to move.
सर ऑसिलेशन
In this circle, no beta, it is pure rotation na. It is able to move. Let's say we are having an analog watch, yes or not?
Yes sir.
In which 3 different hands are available, yes or not?
Yes sir.
Yes,
And
sir.
all of these hands are hinged at point na.
Sir, yes sir.
Yes, sir.
So all hands are able to make a complete rotation, or any of them is capable of doing oscillation only?
सर उसमें सर ऑसिलेशन सर उसमें रोटेशन होगा सर.
All are able to perform the pure rotation na.
Yes sir.
So that is the same case now.
Yes, sir.
If I am saying that, say this is the link whose name is OA, and this link OA is hinged at point O, and it is given that it is having an angular velocity of omega. What does it mean? It is going to perform the pure rotation, yes or not?
Yes, sir.
So say this link is in the pure rotation. Yes. If I'm saying that we are having another link whose name is O dash A dash, and at instant t equals to 0, the location is this, and after t equals to 1 second, the location is this. Which kind of motion it is going to perform?
Sir, linear, rectilinear.
Or specifically, I can say it is going to perform pure translation.
Yes sir. Translation.
It is going to perform a pure translation. So broadly, we are having only two kind of motion. All are except these, all are having the some type of combination. Yes or not?
Yes, sir.
We are certainly having only two kind of motion. First one will be the pure rotation, and another one will be the pure translation. हाँ या ना, यहाँ तक क्लियर है?
Yes, sir.
अब मैं आपसे बोलता हूँ कि just let's say for a time being, I'm saying that कि at instant t equals to 1, say this is the link again OA. At t equals to 1 second, the location is this, and when the time progresses after t equals to 2 seconds, the location of this link is this. So can anyone is able to tell me which kind of motion the link is having?
Sir, translation and rotation both. सर पहले ट्रांसलेशन हुआ है फिर सर रोटेशन भी हुआ है थोड़ा सा.
क्या आप मुझे ये सर्टेनली बता सकते हैं क्या कि पहले ट्रांसलेशन द लिंक हैज परफॉर्म द ट्रांसलेशन फर्स्ट देन इट हैज
नो
मूव?
सर सर्टेनली नहीं बता सकते
कोई मुझे
सर।
बता सकता है? Which kind of motion it is having? It is having a combined motion, yes or not?
Yes, sir.
यस सर।
It is having the combination of rotation plus translation. हाँ या ना?
यस सर।
Now wait, I am moving at this segment only. If I have to calculate the velocity of any point on the given length OA, can I calculate the linear velocity of any point on this given length? So answer is yes. Sir, just let me know what is the length of this link. So I will say that the length of this link is 2 centimeter and the angular velocity of this link is 10 radian per second. So I can easily calculate the you can say the linear velocity of any point on the given link, yes or not?
Yes, sir.
And the direction of that velocity will be perpendicular to that link only. Through the relative velocity method I can calculate na.
Yes, sir.
बेटा रिलेटिव वेलोसिटी मेथड से अपन को पता है ना कि द डायरेक्शन ऑफ लीनियर वेलोसिटी इज ऑलवेज परपेंडिकुलर टू द गिवन लेंथ, and as we are having the angular velocity in the clockwise direction, then the direction of the linear velocity is on the right hand side, yes or not? If it is given into the anti-clockwise direction, then we are having the direction of linear velocity in the left hand side, yes or not? So we can
Yes,
calculate
sir.
the linear velocity for the pure rotation. It is very much easy to calculate the linear velocity for the pure rotation case, yes or not? Or I can say if it is going to perform the pure rotation, then it has to move into the circular path, definite circular path, yes or not? Yes or not?
Yes, sir.
Yes, sir.
अगर मैं आपसे बोलूं कि बेटा t equals to 4 सेकेंड पे what will be the velocity of linear velocity of point A, so you will say that कि sir don't worry, I have to draw a tangent at this location and it will give the direction of this point A, yes or not?
Yes, sir.
It is very much easy to calculate the linear velocity into the pure rotation, yes or not? If it is pure translation, then it is very much obvious that we are having the linear velocity only. हाँ या ना? And if you are not having that kind of exposure, then I can calculate the distance, from which distance it has moved, yes or not? Say this distance is s, and let's say it has moved through 1 meter in 1 second. So are you able to find out the velocity? हाँ या ना? From t equals to 0 second to t equals to 1 second, the point A dash has moved through 1 meter. So can you able to identify what through what distance O dash had moved? It is also moved through 1 meter, yes or not? अगर मैं बोल रहा हूँ
Yes,
कि
sir.
t equals to 0 second से t equals to 1 second, A dash has moved through 1 meter, then what we can say about the point O dash? It also has moved through the 1 meter only, yes or not?
Yes, sir.
If I'm saying that just let me know what will be the how much distance B dash has moved. So again you will say that sir, it is also going to move through the 1 meter only, yes or not? हाँ या ना? मतलब any point at link O dash A dash, all the points has moved through 1 meter only, because it is moving into the pure translation only, na?
Yes, sir.
So all the points on this link has moved through 1 meter only. Yes or not?
Yes, sir.
So can we calculate the linear velocity for the given link?
Yes, sir.
How we can calculate?
Sir,
Velocity is total
linear.
distance traveled upon total time. Yes or not?
ds upon dt, sir. Yes.
So total distance traveled is 1 meter, and the total time which has been taken by this link is 1 second. So the velocity will be 1 meter per second. Yes or not?
Yes, sir.
So it is the velocity of point A dash or point B dash or point O dash or the link O A dash.
Sir, entire sir velocity, sir, from
Entire
0
link
to
is
1.
having the same velocity because it is moving in the pure translation. But is this the case with the pure rotation also? Or all the points on the same link is having the different linear velocity? जैसे प्योर ट्रांसलेशन में सारे लिंक की वेलोसिटी 1 मीटर पर सेकंड है. इफ यू आर गोइंग टू मार्क एनी पॉइंट ऑन द गिवन लिंक, all are having the same velocity only. Is this the same case with the pure rotation also? Yes or not?
सर यस सर, उसमें भी सर यही होगा सर, सारे इंस्टेंट पे
नहीं
सर.
होगा ना बेटा, नहीं ना. If I am saying that कि just give me the velocity of point B, so the velocity, linear velocity of point B will be equals to the linear velocity of point A.
सर बट सर वो कांस्टेंट स्पीड से ही तो सर रोटेट करेगा ना सर, प्योर रोटेशन तभी तो
It
होगा
is
ना.
having the constant angular velocity, but the radius is changing na.
सर बट सर सर्कुलर
एक
आर्म तो
मिनट,
उतना ही होगा ना.
एक मिनट. Say this is the point A, this B, this is the point C. This is 0.5 meter. This is, sorry, 0.5 centimeter. This is 1 centimeter, and A is located at the 2 centimeter distance. Okay. And we also know that V can be written as R omega. Yes or not? Omega is fixed
Yes,
for
sir.
entire length, but is
Yes, sir.
the radius for entire length is fixed, or it is changing from point to point?
सर पॉइंट टू पॉइंट चेंज होगा सर रेडियस.
If I am saying that B is moving in this small radius, so is it having the same linear velocity as the A have?
नो सर.
So both are having the different velocity, different linear velocity. Yes or not?
यस सर.
But in the case of pure translation, all point on the given link is having the same linear velocity.
यस सर.
इतनी बात क्लियर है कि नहीं? तब तो अपन आगे बढ़े, नहीं तो कोई मतलब
Yes,
नहीं
sir.
है.
क्लियर है सर.
किसी को बेटा डाउट? किसी को डाउट? अभी मैं पूछता हूं किसी से. पाठक, एकलव्य पाठक.
यस सर.
समझ आ रहा है?
यस सर.
क्या आप समझाया मैं, बता.
सर यही से सर पूरा आपने सर मैकेनिज्म समझाया है सर पूरा.
सो रहा है बस.
यस सर.
सो रहा है बस.
हो रहा है सर.
सो रहे हो ना?
नहीं सर, सो नहीं रहे सर, सुन रहे हैं सर.
क्या समझाया मैंने, बताओ मुझे.
सर ये पूरा आई सेंटर मेथड सर जो आपने समझाया है सर वही सुनने थे.
ठीक है, कंप्लीट करने के बाद
हेलो.
पूछता हूं. हाँ, कंप्लीट होने के बाद पूछता हूं मैं.
ओके सर.
So we have discussed the two case. in the pure rotation, we came to know that at each and every point, the linear velocity is different for the given configuration. But in case of pure translation, all points are having the same linear velocity for the given length. Yes or not? Now I am moving to the new segment in which a link is having the combination of rotation as well as the translation. Yes or not? So at t equals to 1 second, say the location of this link is at OA, and as t equals to 2 second, the new location of this link is at O dash A dash. So can you tell me which kind of motion the link has earlier? Is it rotation or translation? So the answer to this question is we don't know, sir. We are having only the end situation, end point situation. We are not having any idea regarding first it is moved through that much angle, then it has translated, or it has translated through that much of distance, then it has rotated. What does it mean? Okay, I'm going to make the two different situations. Hold. This is the first situation, and again I'm sorry. Say this is the situation for which I'm going to discuss. Say this is the O, A, and this is the O dash, A dash. So it might be possible that it has moved through, say, initially through this angle, then it has translated. What does it mean? Initially, I can assume that it has moved through certain angle, say this is the theta, then it has translated through this place to that place. Is it possible or not? Is it possible or not?
Yes, sir.
And the second situation,
Possible.
and the second situation which we can say that it has moved through, it has moved through, it has translated through that distance initially, then it has moved through that angle. Yes or not? Yes or not?
Yes, sir.
ये दोनों पॉसिबिलिटी है.
Yes, sir.
पहला कौन सा हुआ ये अपने को पता है क्या? We are having any idea which kind of motion the
No,
link
sir.
is earlier have? So the answer is no. We are not having any idea regarding this.
ये नहीं था.
Which kind of motion it is having earlier. So these both are the possibility. So how we are going to calculate the linear velocity of that link or linear velocity of any point on the given link? हाँ या ना? अगर ये pure, it is the case of pure, if it will be the case of the pure rotation like this, so we can calculate, yes or not? Because we are having a formula equals to V equals to R omega. Yes or not? हाँ हाँ बेटा बताएं.
सर किसी एक में सर चेंज कर लेंगे सर, या तो प्योर रोटेशन या तो प्योर ट्रांसलेशन, फिर सर कैलकुलेट करेंगे.
वही मैं पूछना चाह रहा हूँ अभी. 1 मिनट का, बस 1 मिनट का पेशेंस रखें. If it is the case of the pure rotation, so we can calculate the velocity of each point on the given link, yes or not? If it will be the case of the pure translation, it is very much easier to calculate the linear velocity of the given link or any point on the given link, yes or not? But it is having the combination of rotation combination of rotation plus translation. Yes or not? And the combination of rotation and translation is termed as the link is having the general motion. The link is having the general motion. Neither it is having the pure rotation nor it is having the pure translation. So we are not able to apply the formula for the pure rotation or pure translation directly to the given mechanism. Yes or not? Yes or not? Are we able to apply the formula for the pure rotation directly? क्या मैं डायरेक्टली प्योर रोटेशन का फॉर्मूला अप्लाई कर सकता हूँ?
सर प्योर रोटेशन में सर कर सकते हैं या प्योर ट्रांसलेशन?
सॉरी
सर दोनों में कर सकते हैं, या तो प्योर रोटेशन हो या तो प्योर ट्रांसलेशन।
क्या मैं डायरेक्टली फॉर द गिवन मैकेनिज्म कैन आई अप्लाई द फॉर्मूला डायरेक्टली फॉर द प्योर रोटेशन फॉर द गिवन केस?
No, sir.
Can we apply the formula for the pure translation for the given case?
No, sir.
If I am having the information about कि initially it has moved through that angle, so are we able to apply this formula directly? अगर मुझे पहले पता होता कि it has moved through certain angle initially, then it has moved translation. It is in the then it has moved through the rectilinear motion. Then we can apply the formula directly or not? Just let me explain again. If I am saying that,
Yes, sir. Then we apply.
If I am talking about the case 1, what does it mean? The link is having the pure rotation earlier, then it has translated through. Yes or not? So for this case, I can apply the formula
Yes,
for
sir.
the rotation initially, and after having the velocity of point A dash, I can calculate for the distance traveled through the translation only. Yes or not? If this will be the case as the case 2, what can I do? I can calculate the distance traveled through the translation only initially, so that we are having the linear velocity for the point A or point O. Then we can calculate the linear velocity for the angle through which it has moved. Yes or not? But we are not having any idea which kind of velocity the link is having earlier. We are having only the end point situation of the link. Yes or not? So we are not able to apply the formula for any of the given case. Yes or not? So what kind of motion it is having?
Combined motion.
Combined motion, and generally it is pronounced as general motion. The link is having a general motion. Neither it is in pure translation nor it is in pure rotation. Yes or not? अब आप कहोगे कि सर उबार डाला आपने, सुबह से यही बात कर रहे हो, तो थोड़ा सा उबना जरूरी है, तभी समझ आएगा. बार बार इसलिए बोल रहा हूँ कि अपने दिमाग में बैठ जाए, मतलब पढ़ना नहीं पड़े दूसरी बार. अब देखते हैं, तो अब मैं कैसे बेटा निकालूं ये कि हाउ वी आर एबल टू कैलकुलेट द एंगुलर वेलोसिटी एज वेल एज द लीनियर वेलोसिटी. तो देखते हैं. से initially the position of link is this, and then it has moved through this. Okay. This is the length. So say initially the endpoints are known as OA and finally the endpoints are known as O dash A dash. ये मत बोलिएगा कि सर ये दोनों आपने अलग अलग जगह बना दिए, ये पॉसिबल है कि नहीं? The link is having the combined motion na, general motion na. So we are not having any idea, certain idea about where this point O will lie. Yes or not? So how we are
Yes,
going to
sir.
calculate the velocity, or we can say the linear velocity. So I will broadly say कि एक सवाल मैं आपसे पूछूंगा कि we are having only two options. Either I have to convert this whole motion into the pure translation, or we can or it is very much good to convert the whole motion into the pure rotation. मतलब मैं ये पूछना चाह रहा हूँ कि इस जनरल मोशन को किस में कन्वर्ट करना बेहतर होगा? We have to convert it into the pure rotation, or we have to convert it into the pure translation. Which case will be very much of importance? किस में कन्वर्ट कर लें? नहीं समझ आई बात? आई कि नहीं जो सवाल मैंने पूछा?
Yes, sir.
How many cases we are having for the analysis of velocity?
Two.
Two. First one is the pure rotation case, and second one is the pure translation case.
Pure translation.
We are having the formula for these two cases only. Yes or not?
Yes, sir.
Either I can calculate the velocity through total distance traveled by total in total time, or we can calculate the velocity equals to r into omega. Yes or not? So which case is suitable for this general motion to convert?
Pure translation.
Why?
Calculation easy होगा.
बेटा कैलकुलेशन तो इजी होगा, लेकिन कैन वी कैलकुलेट द movement of angular movement of this link through the translation?
No, sir.
हाँ या ना?
No, sir.
So we are having only one option. Yes or not? We
Pure
have to
rotation. Yes.
convert this whole general motion into the pure translation. Yes or not?
Yes, sir.
So what we have to do is I am going to join these end points. I'm going to join this end points from A to A dash. So क्या आप मुझे बता सकते हैं क्या कि if it has moved through A to A dash, the direction will be definitely in this direction. The velocity direction of velocity will be in this direction only. Either it has moved in the translation initially, then it has moved through rotation, or it has moved through rotation initially, then it has moved through translation. हमेशा इसी लाइन के along होगी. The direction of velocity, linear velocity, will be in this direction only. Yes or not? हाँ या ना? नहीं समझ आई ये बात? देखते हैं. मैंने बोला कि ये दोनों केस पॉसिबल थे ना, तो अगर मैं इसको यहां से यहां तक जोड़ देता हूं, if I am going to join these two end points, so always the direction of linear velocity will be in this direction only na. Either it will be the case or it will be the case. हाँ या ना?
Yes.
So what I have to do is I have to join the same endpoints of the given link through a straight line. Yes or not? This will give the direction of that point of the given link. Yes or not? मेरी बात को समझ पा रहे हैं कि नहीं मुझे पता नहीं, जवाब आने का होगा। पांडे समझ आ रहा है कि नहीं? अंकुर पांडे ठीक। Next, what I have to do is I have joined the endpoints, one endpoint of the given link. Similarly, I can join the second endpoint of the given link. Yes or not? The direction of the velocity will be in this direction. Linear velocity will be in this direction only. Yes or not? हाँ या ना? हाँ या ना? हाँ या ना बेटा?
Yes, sir.
अबे बोलते रहते हो तो थोड़ा सा मुझे लगता है ना बेटा कि I can able, मतलब I am motivated that you guys are getting the point. If I'm not getting
सराउंडिंग की सर सराउंडिंग को वही सारे ना बार बार म्यूट अनम्यूट करना पड़ता है.
Okay. So if I'm saying that कि any point on the given link is moving in this circular path, what does it mean? It is moving in the rotation or in the translation?
The rotation.
Rotation. Very good. If I'm saying that कि say this is the direction of linear velocity at given at different instant. Say this is the t equals to 1 second, this is the t equals to 2 seconds, this is the t equals to 2, this is the t equals to 3. तो क्या आप मुझे बता सकते हैं क्या कि what is the length of this link? Yes or not? So you can say that कि sir don't worry, we are having a very simple solution. Just draw a perpendicular to all of this link. This will be passing through a single point, given point, because it is moving in the circular path only. Yes or not? So all the perpendicular to this given direction will pass through the same point, and that will be the center of this circular path. Yes or not?
Yes, sir.
So I can say that कि sir this is the length of this link. हाँ या ना?
Yes, sir. सबका सेम होगा सर.
सबका सेम होगा. अब आपने मुझसे बोला कि सर we just want to convert this kind of general motion into the pure rotation. So what we have to do is we are having the direction of linear velocity for point A. So you are saying that ki, sir, this will follow this path. Yes or not? If I am saying that ki, if this point A dash is moving in the circular path, and I have to find out the center through which it is moving into the circular path, what I have to do? मेरी बात को समझेंगे. मैंने बोला कि सर यहाँ पे डिफरेंट आपको गिवन था डायरेक्शन, और मैंने आपसे पूछा था कि व्हाट इज द सेंटर ऑफ दिस रोटेशन. सो व्हाट यू हैव डन, you have draw a perpendicular to each given direction. Yes or not? समझ आ रही है कि नहीं बात? फिर से देख लेते हैं. मैंने बोला कि सर ये 4 डिफरेंट गिवन डायरेक्शंस हैं किसी लिंक के, और मैं आपसे पूछना चाह रहा हूं कि सर व्हाट इज द सेंटर ऑफ रोटेशन. सो व्हाट यू हैव टू डू इज you will say, sir, draw a perpendicular at each link. Wait. Just draw a perpendicular बेटा रुक जाएंगे, थोड़ा सा ये रुक गया, पता नहीं क्यों रुक गया। कितने बजे तक बेटा क्लास चलती है? 45 तक ना?
यस सर।
Yes, sir. 10:45.
ओके ओके। हाँ, तो if I am giving you these directions कि बेटा the direction for the given link is like this, and just I want to know the center of rotation. So what I have to do is I have to draw a perpendicular to each given link or each given direction, and where all are getting intersected, you will say sir, this will be the center of rotation. Yes or not? तो सिमिलरली मैं आपसे बोल रहा हूं कि इफ
Yes, sir.
ए आप चूंकि अपन को इस जनरल मोशन को वी हैव टू कन्वर्ट इनटू द प्योर रोटेशन and we are having the direction of linear velocity, say a dash. So can anyone is able to let me know ki where the center of the center of rotation of this point a dash will lie? What I have to do? You will say that ki sir, draw a perpendicular at given length a dash. Yes or not? I can draw a perpendicular at any location. हाँ या ना? मैं अगर पूछूं कि ए डैश अगर रोटेशन में मूव कर रहा है, so it will be the direction of linear
Yes, sir.
velocity. हाँ या ना? तो इसकी डायरेक्शन मुझे निकालनी है।
Yes, sir.
What I am going to do is I will draw a perpendicular to this a dash. Yes or not? मुझे नहीं पता कि कहां तक जाना है, बस आई एम रैंडमली ड्रॉइंग अ परपेंडिकुलर। यस और नॉट? इसी लाइन पे कहीं सेंटर ऑफ रोटेशन इसका मिलेगा। यस और नॉट? हाँ या ना? हाँ या ना बेटा? मेरी बात समझ?
यस सर।
इस लाइन के अलावा कहीं मिल सकता है क्या? अभी आप मुझसे ये पूछने वाले होंगे कि सर आपने यहीं से क्यों ड्रॉ किया था, आपने यहीं से क्यों ड्रॉ किया था, आपने यहीं से क्यों ड्रॉ किया था, आपने यहीं से क्यों ड्रॉ किया था। तो आई विल से दैट कि फर्स्ट आपको द फर्स्ट थिंग, चूंकि ये सारी चीजें बचपन की इसलिए मैंने ज्यादा डिस्कस नहीं की, द फर्स्ट थिंग विच यू हैव टू डू इज यू हैव टू ड्रॉ अ सर्कल in the way that all the points are tangent to this circle. Yes or not? Then only I can draw the perpendicular. नहीं तो आप बोलेंगे सर परपेंडिकुलर यहाँ से भी तो मैं ड्रॉ कर सकता था। सर मैं यहाँ से भी तो ड्रॉ कर सकता था, लेकिन यहाँ पे सर्कल के टेंजेंट है क्या इस लीनियर वेलोसिटी के डायरेक्शन के? नहीं है। यहाँ पे है क्या? नहीं है। यहाँ पे एग्जैक्ट टेंजेंट है। यहाँ पे है क्या? नहीं है। यहाँ पे एग्जैक्ट टेंजेंट है। यहाँ पे है क्या? तो है। तो यहाँ से हर जगह से ही मैंने परपेंडिकुलर ड्रॉ किया, मैं कहीं से भी नहीं कर सकता हूँ। ये बात समझ पा रहे हैं ना कि क्यों मैंने यही लोकेशंस पकड़े? तब आप बोल पाएंगे कि सर या तो मैंने
Yes,
ये
sir.
लाइन ड्रॉ कर दी तो इसी पे कहीं सेंटर लाई करेगा, द सेंटर विल लाई एट दिस लाइन ओनली, और आई कैन से द सेंटर विल लाई एट दिस लाइन ओनली, and where the exact center will be located when these two lines are getting intersected, then only I will get the a single point. हाँ या ना? Similarly, the point O has moved through O dash. So what I have to do is I have to again draw a perpendicular at this. Yes or not? So the rotation, the center of rotation will lie at this point, say M L N K. Say this is the N K. हाँ या ना? A dash वाला क्या बोल रहा है कि where it will be lying at the line N K, और O dash वाला क्या बोल रहा है कि it will be lying somewhere on the line ML. Yes or not? But we are we having the exact point till now? क्या अभी तक मुझे एग्जैक्ट पॉइंट मिल पाया कि नहीं? Are we having the center of rotation till now? So the answer is no. So what I have to do is I have to extend both of these lines. I have extended. Now I'm going to extend this also. At some location, it will be, both line will be intersecting to each other. Yes or not? And this will be the eye center. अब ये आई सेंटर से मुझे क्या दिखेगा? कोई मुझे बता सकता है क्या? इस आई सेंटर से मुझे क्या दिखेगा?
सर यूनिफॉर्म दिखेगा सर वेलोसिटी.
यूनिफॉर्म क्या? किस which kind of velocity the link is having when I'm sitting the eyes on the eye
सर
center?
ट्रांसलेशन
नहीं ना बेटा. ये अब मैं पूछूं कि IM क्या है, तो यू विल से कि सर इट इज द रेडियस ऑफ द रोटेशन द पॉइंट O इज हैविंग. मतलब IM अगर रेडियस है तो पॉइंट O मुझे मूव करता हुआ सर्कुलर पाथ में दिखेगा कि नहीं? यस और नॉट? अगर मैं रेडियस IN को देख रहा हूं तो इसका मतलब क्या है कि the point A dash is moving in this circular path. Yes or not? हाँ या ना? जैसे आप मुझसे बोलते थे कि सर, जैसे आप मुझसे बोलते थे सर, एक मिनट बेटा, एक मिनट बस. जैसे आप मुझसे बोलते थे कि सर दिस इज द लिंक विच इज इन द प्योर रोटेशन, तो क्या अलग अलग पॉइंट्स इसके अलग अलग सर्कुलर पाथ में नहीं मूव कर रहे थे? यस और नॉट? दिस पॉइंट इज मूविंग इन दिस सर्कुलर पाथ, दिस पॉइंट इज मूविंग इन दिस सर्कुलर पाथ, दिस पॉइंट इज मूविंग इन दिस सर्कुलर पाथ. यस और नॉट? हाँ या ना? हाँ या ना?
यस सर.
Yes, sir.
So similarly, to say this is the center of rotation, I, and if I am saying that ki IM is the center, radius of this length, so O dash will seems to be move in the pure rotation. Yes or not? Through radius IM.
Yes, sir.
If I am talking about what will be happening with point A, so you will say that ki sir, the point A is having the radius IN. Yes or not? And it is moving in the circular path which is having the radius is equals to IN. Yes or not?
Yes, sir.
Means if two end points of the given link is seems to be move in the rotation, then what will happening with the intermediate points of this link? What does it mean? If I am asking about what will happening with this point B, say, what will happening with this point C, all are seems to be moving in the circular path or in different type of motion. मतलब B और C भी सर्कुलर पाथ में किसी न किसी रेडियस के लॉन्ग घूम रहे होंगे या ये ट्रांसलेशन में होंगे? So you will say that कि sir don't worry, just join the end points of this B. Say B has reached to this point. So don't worry, just find out the end point of this point C. This will be like this. So I can join, I can draw a perpendicular line again, and it will be passing through this I only. Yes or not? क्योंकि दो एंड पॉइंट्स को आपने पकड़ लिया तो आई मिल गया, ये इंटरसेक्शन मिल गया. मतलब ये बीच के सारे इंटरमीडिएट पॉइंट्स कहां इंटरसेक्ट कर रहे होंगे? ऑल आर इंटरसेक्टिंग एट दिस पॉइंट ओनली ना? यस और नॉट? नहीं समझ आ रहा तो बेटा बोलेंगे प्लीज. अगर दो एंड पॉइंट्स कहीं इंटरसेक्ट कर गए तो इसके सारे बीच के पॉइंट इसी पॉइंट पे इंटरसेक्ट करेंगे ना? They all will intersect at this point only. Yes or not? तो C dash is
Yes.
moving in the circular path is having the radius is equals to C dash का radius क्या होगा? What will be the radius for the C dash?
IS.
What will be the radius for B dash?
IF.
IT. It is T. Yes or not? So if I am asking about what will be
Yes, right.
the
Yes, sir.
angular velocity of link OA, क्या मुझे आप बता सकते हैं? What will be the angular velocity of link OA?
सर रेडियस मिल गया सर, निकल जाएगा सर, फाइंड आउट
Exactly. It will be say VAA dash upon IN, or alternatively we can say that it will be equals to VB dash upon IT, or we can say that it will be VOO dash upon IM. Yes or not? All are all will be same or will be different? ये सारे आपस में बराबर होंगे या अलग अलग होंगे? All will be same because at each point linear velocity is different and the radius is different. So the ratio of all comes out to be the same, which will be the angular velocity of omega OA. Yes or not? So I hope that till now everything is clear to you. Yes or not?
Yes, sir.
हाँ, तो कल मैं थोड़ा सा डिस्कस करूंगा, एक अच्छा सा न्यूमेरिकल कराऊंगा, इसके बाद अपन इस टॉपिक को रैप अप कर देंगे. ओके, थैंक यू क्लास.